Welcome to 15-3 area of a triangle. This section is very short and quick, but I want you to take a minute, pause the video, and please do the warm-up of finding the area of each triangle given. Alright, so hopefully you remember from the area of a triangle from geometry is 1/2 the base times the height. So if we look at number 1, we see that it's 24 for the leg, 25 for the hypotenuse. So hopefully you remember your triples. It's 7. If you don't remember your triples, you'd have to use the Pythagorean theorem. But then we know that the area of this triangle is going to be 1/2 times the base, which is 24. And remember, the height also forms a right triangle, or excuse me, a right angle. So 7 would be your height. So multiplying those together gives you an answer of 84 square units. Number 2 is a little more difficult because you really don't have the height of the triangle, because remember, the height of the triangle is the altitude, which forms a right angle with a given side. So in this case, I drop a perpendicular from a vertex to the base 10. And because it's isosceles, if you remember from geometry class, that would make these two sides basically bisected. So therefore, they would each be 5. And therefore, if you did the 13, 5, and you notice that 13 is the hypotenuse and 5 is the leg, then you would also notice that the height then would be 12. So we do 1/2 times 10 times 12, and we get 60 square units. Now the last one is the hardest one. Again, we don't have the height, so we're going to have to drop the height. However, because it's not isosceles, we do not know that the 20 would be bisected. So therefore, we're going to have to use trigonometry. If we look at 40 degrees and we look at h would be considered the opposite side, and 9 would be considered the hypotenuse. So if we do the sine of 40 degrees is equal to h over 9, we can multiply through by 9, so we'd have 9 times the sine of 40. Now before we actually multiply that out, I want to leave my answer basically in that form, because I don't want to round to the very end. So I'm going to stick with what I've been doing. 1/2 times the base, which is 20, times the height, which is 9, times the sine of 40 to get my answer. The final answer is going to round to about 57.9 square units. But this third problem is very important to look at, because if you look at what happened in this problem, 29 and sine of 40, you'll notice that there's a relationship there between those three. It's almost that SAS case, or it is the SAS case. So as we roll down to the bottom here, it says, when finding the area of a triangle where SAS is the given information, the formula 1/2 BC sine of A can be used, where B and C are the side lengths and A is the included angle between B and C. Don't get caught up too much in the letters B, C, and A. I just use those to reference basically a side angle side case. So it might be a good idea when you're given a problem to draw the triangle out. So you have a triangle ABC. B is 25 degrees. Little a is 17. And little c is 33. If you need to help, visualize it, you can see that it is side angle side. So rather than redraw the triangle and do the math in problem number 3 above, we can just simply say 1/2 times 33 times 17 times the sine of 25. And that will be our answer to our problem, which is 118.5 square units. That's the lesson for today. Good luck finding the area of the triangle, and I do believe when you do your assignment, you'll have some twist questions that you'll have to rely on your geometry for a little bit, but I think you guys can handle it. Good luck.